Yeah. Let's start off. So last thing we did was this, a ring and a square frame. Hope everyone has resolved the questions again. It's important after every class you resolve whatever we do in the class. If you just refer the notes like a novel and see, nothing will go into the head. Even when you see the same question after a month, you will feel like, oh, I have seen this somewhere. And the next part is the radius of curvature. So what is this radius of curvature? So basically a segment of a curve can be treated as a part of a circle. The radius of this circle is called radius of curvature. What do you mean by this? Think about this. For example, let's say, tomorrow you're a civil engineer or architect and you're trying to build a, railway metro track, or maybe, that Imagicam, you have that nitro ride, now something like this sort. Now, when you build this nitro car ride, this is some just random curve, isn't it? So when you ask for construction, how do you tell them, like, you can't say I want a curve, right? They won't understand what you're talking about. So what we do, we tell them, see, this part is there. This part belongs to a big circle like this. So we will say this part, radius is 10 meters. The length of this piece is 5 meters. So this is how you send specifications. You will say, I want a curve whose radius is 10 meter. Matlab, if you made a full circle, that will be 10 meters. Uska sirf 5 meter ka length chahiye. You getting the meaning of it? And then you will say, I will need another one here. Let's say this radius is maybe 4 meters, and let's say length is again 4 meters. You're getting? So you will say, I want a piece of 4 meters, which is radius to 4 meters. So this is how you send the specifications. And then you tell them, I need, this is a bigger one. Let's say radius is 20 meter, whose length is 6 meters. You're getting how you're constructing this whole piece? So basically you're constructing that entire curve with sections of a circles. And when you combine them now, it looks like a random curve, isn't it? But in reality, when you're constructing, if you just tell the person to, do a random curve, you won't understand what you're talking about. This again will be a smaller piece, let's say a radius of 3 meters, and let's say you need a length of maybe 4 meters, or maybe length of 2 meters. So this is how you send the specifications. And once you get these pieces, you assemble them. Are you getting what I'm saying? So if you have a random curve, something of this sort, so this piece can be treated as a part of a circle. This piece here can be treated as a part of a circle. This piece here is treated as a part of a circle. Here, this piece is treated as a part of a circle. Right. And for this each piece, you can define the radius R1, so R2, R3, and so on. So you can, so basically a covered part can be treated as an assembly of small arcs. And you can see here, sharp turns have small radius and large turns have big radius. Just think about it. If you are the manufacturer, let's say for a metro, if you're building a metrocal line, so metro is straight and you want to take a turn like this, right? Will you just go and tell them, give me a curved piece for metro? He will not understand what you're talking about. How do you specify then? How do you tell him like what you want to construct? Getting it? So for you, it might be a random curve, but end of the day, when it comes to construction, you need to have a certain kind of, a standard for us to manufacture stuff. And out of all the things, making a circle is the easiest one, isn't it? If you ask someone to make a parabola, it's a pain, but telling them to draw a circle is still manageable. So even if you ask them to make a parabola, you know what they will do? They'll make it pieces of circles से assemble करेंगे. So it will be close to a parabola again. So works. Clear with this? I hope Aaron got an idea what is the meaning of radius of curvature. So when we say radius of a circle, there is no problem because in case of a circle, right, every piece belongs to the same circle. So all have R only. But when you take a random curve, R is not defined. Every point has a different R. Sure, everyone? So how do you find this radius of curvature? Now, there are two ways you can do this. One is using physics and one is mathematically. We'll see both. So first thing, physics-wise. Others, do keep your cams on. So the straightforward thing is, suppose if a body is going with V, so you are saying this is a part of a circle. And let's say if it has an acceleration A like this, you can divide the acceleration into two parts. The A perpendicular component and A parallel component. So this A perpendicular is your A centripetal. And your A parallel is your A tangential. So the acceleration in the tangential direction is tangential and the perpendicular is A centripetal. And we already know A centripetal is V square by R. There, your radius of curvature is V square by A perpendicular. So don't resolve, you have to keep the velocity as it is, resolve the acceleration. So resolve the acceleration along the velocity and perpendicular to velocity. The perpendicular one is the centripetal and the parallel one is the tangential. There, this is your radius of curvature, which you already know. So this R is actually the radius of curvature. We never had a problem because we always took a circle, so we never had an issue. Clear? Let me show you one more example. Any doubt so far? Let's see one more example. Your favorite projectile motion. So when you project a particle with u and theta, this thing goes in a parabolic path. So even this, at any instant, you can treat this as pieces of circles. You can treat like this. So during this motion here, at any instant, so if you treat this as a part of a circle, so even a projectile motion can be treated as a part of a circle. So at this point, you have, this is your velocity. And what is the acceleration here? Let me make this smaller, this thing looking too big. If this is a part of a circle, this is your velocity, this is your gravity, isn't it? Gravity is always acting down. That means you can resolve this gravity into two parts now. I can resolve the gravity. Now remember, this angle is alpha. This will be alpha. This will be g cos alpha. And this will be g sine alpha. So g cos alpha is your acentripetal. So they can even ask a question like this. Find the tangential acceleration of a projectile motion after some time. Getting it? Even that projectile motion can be treated as a non-uniform circular motion whose radius is changing. And g sine alpha is a tangential. And here, if you want the radius of curvature is v square by a centripetal, which is v square by g cos alpha. But we already know during projectile motion, u cos theta is equal to v cos alpha. So I can write v is equal to u cos theta by cos alpha. So we get radius of curvature is u square. Because u and theta are given by g cos cube alpha. That is your radius of curvature. And if you see at h max, alpha is the 0, so radius of curvature is minimum, which is u square cos square theta g. So you get the smallest circle at the highest point. This is your radius of curvature. This is also a good one. A centripetal is g cos alpha. A tangential is g sine alpha. There, your projectile motion. Have a look at this. Because tell me one thing, at that instant for the particle, does it really know it is going in a parabola? At that instant, it will feel in this section belongs to some circle, isn't it? So even you can treat the parabolic motion, the projectile motion as a non-uniform circular motion. Have a look at this. So this is one way to calculate radius of curvature, physics ka terms mein. There is a mathematical way. We will see that in the end because that is a little bit out of portion. Any doubts? Anyone not convinced with anything? Anything is confusing? Anything looks weird? Please ask. Clear, Purvaja? You didn't like it? You're looking like, sir, I like projectile motion. You messed it up right now. Yes, a feeling tha. Nahi? Sometimes happens. All clear? Ahana, got this? Can I go ahead? Ojas? Let's go ahead. That's it. That is a concept wise. That is the only concept you have in radius of curvature. Let's see a question. So a particle is projected 20 meters per second, 25 meters per second, 53 degrees. Find the acentripetal, atangential, and radius of curvature. Do I get a good numbers? T, we will see. We'll just put it. The numbers we'll see later. T is equal to 1 second. I think I'll get some bad numbers there. Okay. Let's get this. 25 meters per second at an angle 53 degrees. Gravity is there. First thing, what you have to do, you have to find alpha. Try. I'll give you a minute more. Okay, numbers are bad. Let's see. So somewhere t1 second you will be here. So at this point, the velocity is v. This is your angle alpha. This was your g. The same diagram which I drew just now. This was alpha, and this was g cos alpha was a centripetal, and g sin alpha was a tangential. So the whole thing is about finding that alpha there. And we know tan alpha is v vertical by vx at any instant. So this is u sine theta minus gt. I hope you didn't forget from projectile, u cos theta. That is 25 sine 53. Sine 53 is 4 by 5 minus 10 into 1 by 25, 3 by 5. That is 5, 5, 5, 4, 20, 10 by 15, 2 by 3. There you go, tan alpha. And I taught you this. If you know tan alpha is opposite side by adjacent side. So the hypotenuse will be root 13 there. From there you can find sine alpha and cos alpha. So sine alpha is 2 by root 13. Cos alpha is 3 by root 13. So your acentripetal is g cos alpha, 3g by root 13. A tangential is 2g by root 13. And radius of curvature is v square by acentripetal. V is, you can calculate that also. U cos theta is v cos alpha. U cos theta is 15 and cos alpha is 3 into root 13. So that is 5 root 13. That is 25 into 13 by 3g root 13. Yeah, numbers are not great. You can leave it there. Clear, everyone? So the whole game is finding that alpha. Once you get that alpha, you'll get everything. You'll get v ka value, you will get cos alpha, sin alpha, everything you can get. This is one way of asking radius of curvature. If they ask you H max, that is the most easiest one. Because at H max, what is the velocity? U cos theta, which you know. What is the acceleration? G. There's no tangential acceleration at H max. So that would be the easiest question. That would be a mains or a bits level easy question. Find the radius of curvature at the highest point. Clear? Next one. Any doubts on this? Turn in the page. Niharika, clear? Clear. Devansh, Arnav, Arnav, clear? Next thing. This is a good question. मतलब repetitive question even in mains. So you can expect this as a standard model. Something like this. You have a track like this. So two broad turns and then two sharp turns. So here we have a vehicle of mass m is going with constant speed u. Gravity is there. So this point is A, this point is B, this point is C, and this point is D. So a vehicle moves along a curved track. With constant speed u. Arrange the normal reactions in ascending order, meaning the smallest to biggest, or biggest to small, it doesn't matter. Which is greater, which is the smallest. Arrange the normal reactions at A, B, C, D. Exam options will be like Na greater than Nb greater than Nc greater than Nd. These are 4 options they'll make. Try, it's a good one. Standard model.
Sir, the radius of each of the circles won't be mentioned.
नहीं देख के पता चल रहा है ना, कुछ तो फील आ रहा है ना, बिग एंड स्मॉल नहीं.
हाँ सर, मेरे हिसाब से तो दिख रहा है कि ए का सर्कल इज द का रेडियस इज द बिगेस्ट.
बस हो गया इतना ही. You need that only. Told you na, I wrote a statement here. Remember, sharp turns have small radius.
Yes, okay sir.
बस इतना आइडिया चाहिए, because see ना, they're not asking exact values also ना, सिर्फ ऑर्डर चाहिए. Question will be like this only, they won't give any more data. It is going along with constant speed. Speed is same everywhere. Arrange the normal reactions at A, B, C, D. Right, take a minute or 1.5 minutes and figure it out. We have 2 answers. Vihan and Bojas. Let's see. Let's see. Others also try, type your answers in a minute, then we will see. You got an answer, do type to the co-host, not the host. Here. Host is my tab where I'm writing. I won't be able to see you. We have 2 answers so far. Others? Two, four. We have 3 different answers. So Vihan Agarwal also has mentioned something. Arush. Descending order. Okay, let's see. I actually don't remember the answer, but let's see. First thing, let's try to draw an FBD and check it out. So at this point here, understand the circle is like this, and like Ansh said, this is a big circle. Itna to pata hai, exact radius pata nahi hai. B also is a big circle. C is a small circle. D is a small circle. I hope this much is clear. Now, when I draw the free body diagram, look at the forces. This is Na, this is Mg. Since it is going in a circle, I'll draw centrifugal force, mu square by Ra. My observer is on the body, so I'm writing centrifugal force. Now, when you're at B, this is Nb, this is Mg. The centrifugal force is away from the center here, so this is mu square by Rb. When you are here, Nc, Mg, centrifugal force is mu square by Rc. This is Nd, Mg, centrifugal force is mu square by Rd. Now, when you write the normal reactions, you can clearly see Na is Mg minus mu square by Ra. It's getting subtracted. Matlab, this much I know, normal reaction at A is less than Mg. Similarly, Nb, if you look at here, the normal reaction is Mg plus mu square by Rp. So basically, whenever the turns are going down, lower turns, the normal reaction increases. Whenever climbing a hill, normal reaction decreases. So this is the reason when you're going in that Nitro ride, in that Imagica thing, this is what you experience. As you go on this ride, your weight is increasing and decreasing. So you will feel the gravity suddenly increase, your body will suddenly feel gravity is decreased. So your body is, undergoing fluctuation of weight. So it starts releasing all kind of hormones to, it thinks you're dying. It starts releasing all kind of hormones to protect you, and you think you're having fun. That is the thing. And this is mg, and this guy would be minus mu square by rc. And if you look at nd, this would be again mg plus mu square by rd. Now, looking at this, you can clearly see b and d are bigger than a and c. Now you need to see between b and d who is bigger. Now look at this, between b and d, radius of d is smaller than radius of b. Agreed? Therefore, mu square by rd, because it is in the denominator, is greater than mu square by rb. Therefore, nd is greater than nb. That means out of all the points at point D, you will feel the normal reaction is the maximum, or you will think your weight is maximum at D. And normally in a roller coaster ride, that value can exceed 2 to 3 times mg. That means at that instant, you will feel your body ka weight has gone 2 to 3 times. Did you ever notice this thing? Next time, that when you go to a amusement park, observe this. Huh? When people are going in a ride, this is what happens. Huh, Vihan? Agarwal, listening? Focus on the class, everyone. So when you're going on a ride, this is what happens. So when this vehicle is going, if you see now, the sounds will be like this, like people are shouting like, again it comes. Ever notice that? All are shouting, and for a moment, everyone just becomes quiet. Able to remember something like that? All are shouting because of excitement, and then suddenly everyone becomes quiet, and again they shout. Not because everyone decided like, अरे अब चुप रहेंगे. The thing is, when you come to this lowest point of this section, right, the gravity or the weight you're experiencing is almost 2 to 3 times the air is pushed out of your lungs. So there's no air for you to shout. So for a moment you become quiet, and then again once you come up, again air goes inside, and again the voice comes out. Getting it? So it is that it is not everyone decided let's be quiet at the bottom. So there we got nd greater than nb. Now between b and c, we know these two, between a and c, both are smaller, but who is more smaller? Now be careful here, there's a minus sign here. That means whoever subtracts the smallest will be the biggest. So here RC is greater than RA. So again, same story, mu square by RC is greater than mu square by RA, but there is a negative sign. Means RC you're subtracting more. Therefore, NC must be less than NA. Or you can say NA is greater than NC. There. So your final answer, D is the biggest, then comes B, then comes A, and then comes C. That means out of all the points, C is a point, there's a high chance you will fly away from there. So if this was a car chase, and you must have seen in movies, right? The car flies like this. So the high chance of flying away is at point C. At C, the chances of losing contact are the highest. So answer is DBAC. Who got this? DBAC. Purvaja got this. Vihan also got it. Vihan. Yep. Clear with this? Check it out. Quite a good question. That's what I said. It's a good question. It's not tough, but it's little theoretical. This is the kind of questions you can expect in mains. Out of 25, you will find at least like 12 to 15 questions of this sort. If the paper comes like last 4 years. If they decide to harass you, that's a different story though. But fine, anyway, you're preparing for advance, you'll be able to handle it. Any doubts on this? Jainil, clear with this? Arnav? Clear? Arya? Ansh? Arush? Got this? Adi? Vihan Agarwal, got your mistake? Next thing. Sharman, got this? Next one is an advanced question. Let's see how to do that. This would be an advanced paragraph. You have a parabolic frame. Y is equal to x square. That's your equation. Y-axis, x-axis. That is your origin. So here we have a ring here. Ring is going like this. So a ring can slide on this frame. It's like a bead. Now the thing is, this ring ka speed is always u. So a ring slides on this parabolic frame such that its horizontal velocity is always u, not the total speed, only the horizontal component, that is ux. Its horizontal component of velocity ux is u. It's always constant. You're getting it? Means no matter how much you pull, it is always constant. Find a centripetal, a tangential, radius of curvature at 1 comma 1. Now, how it is going with constant, we don't care. There is someone else who is making it do. That is fine. We'll not get into that part. It is going with a constant. Horizontal speed is constant. But just to give an idea, how is the ring actually going? The ring is going like this, isn't it? The ring is going along the frame tangentially. Matlab, this velocity ka horizontal component is always constant. I hope that is clear. The ring is going with some different speed. I don't know how much is that, but that component, the horizontal component of that speed is always constant, which is u.
Sir, is gravity acting on the object?
We don't know. मतलब पूरी ऐसा सोचो ना, even if gravity was acting, some person is pulling it and making sure the horizontal speed is u. So it won't matter. For our question, it won't matter. Because if you say like that, gravity is there, then how will it go on its own with, right? You, matlab, there are other forces also. I should have mentioned about that also. So if nothing is mentioned, it is fine. Matlab, it won't matter in this question, so it's fine. If I had asked you find normal reaction, maybe it would have mattered. But it's a relevant question. So think, take 2 minutes, try to think what to do, how to do anything, and then let's see. Right. Just get some water and come. Let me help you a bit. So if I have to ask you this question, I'll ask you something else first. Can you find the acceleration of the ring? Forget about centripetal, tangential, all that thing. Forget about all that. Find acceleration of the ring. How will you find it? Start from there. So I'll make it even more simple. Find x coordinate of the ring. If the velocity, horizontal velocity is always constant, then what is x coordinate? Horizontal velocity into time. Isn't it? So if I know x coordinate, can you find y coordinate? Yes, y is equal to x square. If I know y coordinate, if I know x coordinate, if I differentiate 2 times, don't I get acceleration in I cap and j cap? Acceleration aa gaya. If I know acceleration, can I divide acceleration perpendicular to velocity and parallel to velocity? Then you got acentripetal, A tangential. There, I think now something must have clicked. Try. I'll give you a minute again. So whenever you see a question and you don't get ideas how to solve, just leave the damn question. Think, okay, whatever data is given, with that, what all things I can get. So instead of trying to solve the question, now we try to do something else. I don't know how to go from A to B, but from A, I can go here, 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 here. So you try to figure out all the possibilities. Most of the time, something will click. Let's see. Let's see, Vihan. I'm not sure about the answer though. It's wrong, Vihan. See, your dimension is not matching, right? God. Radius में u square आ रहा है नीचे में. I don't know about whether you answered right or wrong, but your radius of curvature का dimensions are not matching. 2u square. Maybe that u square shouldn't be there, I guess. Then maybe you would have been right. I don't know. Daksha, you got a centripetal 8 and you got both equal. Okay. Huh, both will be equal. Both are right. Magnitude. Magnitude. How did you get a number? Because there's a u na, Daksha. How did you eliminate u from the options? Root 2u square. What is that? Did you find net acceleration? Net? Near. Let's see. So this is your parabola. So this is your 1, 1. So if I draw a tangent, this is angle theta. Slope is dy by dx, and remember y is x square. That would be 2x, and at x is equal to 1. Nay, it's not 45. Even I did a mistake. Actually, they won't be equal. So we get asked x tan theta is equal to 2. That is the angle there. Fair enough. Now look at this. The x coordinate is nothing but ux into time, and you said u is constant, so this is ut. So and obviously acceleration in the ax is 0 since ux is constant. That is in x direction. When you try to do the study in y direction, I know y is equal to x square, and you said x is ut, so this is u square t square. If I differentiate this, I'll get vy, which is u square 2t. If I differentiate again, I'll get ay, which is 2u square j cap. So if someone asks you the net acceleration, a net is ax I cap plus ay j cap. which is 2u square j cap. So that is the only acceleration you have. So at this instant, if you look at the point here, this is the velocity which is tangential, and this is your acceleration net. And if this angle is theta, drop a perpendicular. This is 90 minus theta. This is 90 minus theta. Making sense? Have a look at till here. Let me show you the next page again. The net acceleration is 2u square j cap. So this particle always has a vertical acceleration 2u square, which is constant. Horizontally, there's no acceleration. Horizontal speed is constant, but vertically, the speed is increasing. So once I got this is your velocity. This was your acceleration, and this was 90 minus theta. So this component would be a cos 90 minus theta, that is a sine theta, which is your a tangential. This is your a cos theta, which is your a centripetal. Tan theta you already calculated to be 2. This is 2, 1, and root 5. So a centripetal is how much? A is 2u square, which is constant. 2u square cos theta, 2u square by root 5. A tangential is 2u square by 2 by root 5. And what about speed v? V bar is nothing but Vx I cap plus Vy j cap. This is Ui cap. Vy is 2u square t j cap. And you said that x is equal to 1. And we know x is equal to ut. So t is equal to x by u. That x is equal to 1, time is 1 by u. So substitute 1 by u there. So the velocity at 1 comma 1 is ui cap plus 2u square 1 by u. There, so the speed would be root 5u. So radius of curvature is speed square by a centripetal, which is 5u square by 4u square root 5. U square will cancel. 5 root 5 by नहीं ये 2 था ना. There, you will get cancelled. Please check the steps. You need to find the speed at that instant, and speed is ux I cap plus uy j cap. Again, what did I do? Step 1, you said horizontal velocity is constant. The moment you hear the word, you should say, yeah, x coordinate is ut. Once you get x coordinate, you get y coordinate. Once you get y coordinate, to differentiate twice, you get the acceleration. Because x may there's no acceleration. Once I know the acceleration and I know the angle from differentiation dy by d theta, I'll get the slope. And then it goes off. It's a good one. You should definitely try this on your own again. Don't worry if you didn't get it now, but the ideas are important. When you see something similar next time, now you know what to do. You learned it. So make sure to take a rough paper tomorrow, sit and do all the questions again. So if you just want to find radius of curvature, there is a mathematical way that will give you the answer faster. Let me show you that also. But any doubts on these steps? Anyone not convinced with anything, please ask. Next one. All clear? Pratik, Ojas, Ignajit, Sharman, clear? Now, this is a mathematical method for radius of curvature. So what mathematics says is, for a given curve, the radius of curvature doesn't depend on with what speed you go, right? Think about it. If I make a curve like this, why will my radius change? Because you're going faster, isn't it? And that is the reason, if you see, the answer came independent of you, isn't it? When you're making a segment, you already made it with a certain radius. Just because the vehicle is going faster, why will my radius change? So let's say if it is something like this, take a small piece here. So let this angle be d theta, let the radius be r. So this small piece which you have, ds, again I'm exaggerating it, you can treat it like a line. So this is the best part. A small arc can be treated as a straight line, or it can be treated as an arc. Because it is so small, everything works. So this is how we get there, theta. So we know tan theta is dy by dx. Differentiate this with respect to x. Tan ka differential becomes secant theta. You'll also get d theta by dx because chain rule. And this becomes d square y by dx square. Double differential. So from here we get d theta by dx will be d square y by dx square 1 by tan theta secant square theta 1 by sec square theta. But this is d square y by dx square, and secant square theta is what? Secant square theta is 1 plus tan square theta. And tan square theta is again dy by dx. That's d square y by dx square by 1 plus dy by dx whole square. So just keep it aside. Now, we can clearly see here, that is one part. The ds is equal to root over, it's a Pythagoras theorem, dx whole square plus dy square. So this ds can be also written as rd theta. Take out dx common from here. This will be root over 1 plus dy by dx whole square. Derivation is not important. So we get radius of curvature will be 1 plus dy by dx ka whole square ka half into dx by d theta. But I already calculated dx by d theta. Take this guy and substitute here. So when I substitute here, that is d theta by dx. So 1 plus dy by dx whole square 3 by 2 by d square y by dx square. I'll write it on the next page again. This is the formula for radius of curvature. Because that's a right angle triangle Pythagoras theorem, ds is also rd theta. So this small piece ds is rd theta arc length. So we're using arc length formula and Pythagoras theorem both together. then it is just a matter of little brute force differentiation and putting it. Let me write down the result again. So it's a good result, you can remember. So the radius of curvature is 1 plus dy by dx whole square, this whole power 3 by 2 by denominator में double differential. Now in our example, let me take an example. So the question just the one which we did. So we had a parabola y is equal to x square, and you wanted to find the radius of curvature at 1, 1. Now look at this formula here. So dy by dx is 2x. D square y by dx square is 2. So when I substitute in this formula, you get 1 plus 2x ka square whole power 3 by 2 by 2. So this is the radius of curvature at any x. So at x is equal to 1, r is nothing but 1 plus, that is 2 square. 2 power 3 by 2 by 2, that is 5 power, so 5 root 5 by 2. Same answer. How do we know d theta and theoretic same as theta? My God, you only said it is theta. So basically, when you're taking a tangent here, you're taking that to be a part of that theta, na? Theta, that RD theta. It's like x and dx ray. X and theta is d theta is a small part of theta, so it is the same thing. I didn't draw the d theta there. You can draw a theta and check it out. Whatever, same thing. It doesn't matter. It is just a convention. Think about it. Where did you get this theta from? Y and x coordinate. Where are you getting ds from? Same y and x. So all those belong to the same theta there. Clear with this?
Sir, can you
Hmm.
make that diagram again?
Which
The
one?
that you connected theta and d theta.
This one.
Yes, sir.
So you're just saying, it is just a convention. See, you could have taken any angle as theta. So this is your tangent, right? Again, this is a very small angle, isn't it? ds, na? Here is a very small angle here. This is theta. So you are considering that like a, aisa socho. So if you say like this is theta, that is d theta, something of that sort. Meaning at an angle theta, you're taking a small angle d theta. Okay?
Theta is the other angle, right?
ठीक है ले लेना. Then this will be 90 minus theta. 90 minus theta का differential is what? D theta.
Oh, okay,
We
sir.
are taking a change, right? It doesn't matter. D theta is simply a change in small angle. So, like I said, derivation is not important. The result is important. It is useful, but again, it is not there in the portion. If at all they ask you, they might give you a little hint about this thing, and then they would ask questions. Mostly a paragraph. Clear with this? Let's see how they can frame question on this. Copy the formula, na? You'll need this now. Copy down that thing. You will need it. Let's see a question. We have a random curve like this. Y is equal to x cubed by 3. Gravity is there. Mu is equal to half. There is a friction also. This point is your origin 0, 0. So on this, we have a 10 kg block, which is going with a speed u is equal to 10 meters per second constant. Find normal reaction and friction at x is equal to 1. Let's get this. See now, Vihan, Puraja, you guys were saying, na, see that thing I drew a random curve, right? I could have drawn a curve like this also. So then I would say, at this point, this is the tangent, and I will say this is theta. Then I will say I'll go a small angle like this, and I'll say this is d theta. It won't matter because theta 91 is theta ka differential is d theta only. So it is just a small theta. How do we do this? You need that thing, huh? Focus, everyone. Focus. Give it a try. This would be, if they ask, it will be a good advanced question. √2. Fell into the trap. Did you use the formula which I gave you just now? You didn't use it, right? You used it? Okay. Then you must have the calculation, maybe then. 100 √2. You didn't use Regod. You just took n is mg cos 45. N is not mg cos theta, drunkards. Draw the free body diagram. You will see something there. How did you get 100 √2, right? If mg cos 45 is 100 √2, right? Ishana got it right. 1100 by 2 √2. Someone realized it now. Show you? See. So if you look at the slope, tan theta dy by dx is x square. At x is equal to 1, tan theta is equal to 1, and theta is 45 degrees. Just that is wrong. So somewhere here when the block is there, so this theta is 45. Now listen carefully, everyone. So if I draw the free body diagram, look at the forces. This would be mg cos 45. This would be mg sine 45. There will be friction also, F maximum. Why F maximum? Because it is sliding. So that means this block is not going on its own. There is some external force which I'm not talking about. There is an F external which was not mentioned, but it is there, or else it won't go on its own. Clear? Now, since it is a part of a circle, then you should ask me, sir, why didn't you, do this centripetal force on an incline? On an incline, for a straight line, what is radius of curvature? Infinity. A straight line is a circle with infinite radius. So when you use centripetal acceleration mv square by r is infinity, you'll get 0. Are you getting it? A straight line, mathematically, you can say, is a circle with infinite radius. It is going to bend at infinity. So that's why we never bothered on this, but now it would matter. Since it is going on a part of a circle, there will be a centripetal acceleration, and there is also a normal reaction in. So the most common mistake what people do, they forget the centripetal acceleration there. So n minus mg cos 45 is mass into centripetal acceleration. Is that clear, everyone? So this would be mg cos 45, and centripetal acceleration is mv square by r. This is where people get stuck. They don't know what is r. Then our formula will come. Radius is 1 plus dy by dx. Now, if you don't know this formula, you can't solve this question. 3 by 2 by d square y by dx square. So one differentiation is x square, and double differential will be 1 plus x square ka square, so x power 4 by 3 by 2 by double differential will be 2x. You said x is equal to 1. Did I? X is equal to 1 will become 2. That is 2 power 3 by 2 by 2, which is root 2. There I got the radius ka value also. NB aa gaya. What is friction? F max is mu into n. There I'll get everything. So if you solve with the numbers, you will get 1100 by 2 root 2 or root 2. We have got root 2. Calculate kar lete hain. 100 by root 2, that is m 1000. 1100 by root 2 re. Shana, you got a 2 extra. But did you give me the friction ka value kya?
Sir, I gave friction.
You gave friction ka value. Then theek hai. That is 1100 by 2 root 2. Check. Now, in case you forgot the normal reaction, centripetal acceleration, you would have got n is 100 by root 2, and that answer would be there. Remember this question, huh? This can come in work for energy ka ending mein. Will be used, yes, because speed is constant. Speed change nahi kiya re, nahi to solve nahi kar payenge na. I don't know what is that speed also. So here f external is not given. There is an external force which is pulling it. We don't know how much is that. You can actually calculate that also. If they ask you how much force is pulling you forward, f external is mg sine 45 plus friction. If you wanted, you can find that also. Is this clear, everyone? Check it out. That is the last question in circular motion. That we're done with the chapter. So if you see, there are 4 parts. The first one was circular kinematics. And if you see in circular kinematics, we did have some deadly ones. Especially this guy was good. dr by dt ka thing. And then this was a good one. This is a proper advanced one, that the spiral one. And then we had this concept of centrifugal, centripetal action, centrifugal force is important. So there are a lot of concepts in centrifugal force only, if you remember. And this one, this is an important one. A centripetal is V relative square by R. That RV is the relative velocity. And then this ring one is the very important standard question. Comes in 6 chapters. And then this rod one, I think, is the first kind of time, we have seen integration based on this. Then banking of roads is fine. It's important, but it's a bit tough. And then if you ask me, this is also a good question. This was also a good one. This is an advanced paragraph, and there you saw. Chapter is good. If you see, it is a mixture of everything. You saw everything from vectors, kinematics, NLM, friction, everything here. Next chapter, work power energy, again everything will come. This is how the game will keep going on. Like we'll just keep putting everything. Clear? So we did almost 36 questions, good number of questions. We did some pretty solid ones also. So do make sure to resolve. Again, I'm telling you, your notes itself is a big resource. By the time you finish the full portion, you'll have around 1200 to 1300 questions of chunk. If you can even do this properly, that would help you a lot. The next one, work power energy. We'll start off with the introduction today. This is also another base chapter. Like I said, the difficulty is bumping up, but that's what I'm saying. Keep doing your work, getting it. You're also becoming strong. Some of you are feeling like, sir, my marks are not improving, but you need to ask yourself, if every 2 weeks the chapter is changing, how can your marks improve? Right? So even though you're becoming strong, the issue is the chapters are also becoming strong and you're learning everything new every 2 weeks. So if someone can actually maintain their score, that actually means you're improving. So don't worry, don't worry too much about the marks. Again, this is not school. Focus on your subject, focus on learning, right? Meaning, what do you mean by that? I'll ask you a simple question. See, if I say, I'll give you 10 questions in kinematics. I'm not going to tell you what questions, okay? I'm just telling you, I'm giving you 10 questions in kinematics. How many of you are confident that you can do 7 questions without even seeing what is a question? Maybe see, after I gave you really tough, you couldn't do that. Alag hai wo. I'm just talking about a moderate paper, let's say. If I give 10, how many of you are confident you can handle 7? 8. There. If you say 8, that is confidence. If you say 10 out of 10, that is arrogance. Getting it? Even if you ask me the same question, na, sir, if I give you 10 questions from physics, how many can you do? I'll say 8. I will not even say 9. Getting it? So if you can tell me like that, right, sir, in friction, right, you give me anything, I think I can handle 8. If you have that kind of thing, I think you're confident. That's it. That is the kind of state you need to reach. Wo 8 aayega, nahi aayega, it depends. Paper is easy, you might get everything. Paper is tough, maybe you might get only 4. That is okay, na? That is okay. Getting it, keep the process enjoyable. Don't make it stressful. Getting it, it's a long game, right? In this game, right, you win not because you're doing a lot, you win because you're not burning out. Because others will get frustrated, others will burn out, and they will quit the race. At least in last 10-15 years, that is what I noticed. Thing is, people can't sustain, in order to get that. Let's say if someone is already scoring, just an example, let's say 75 80s, right, and out of 100, I'm not saying don't try, keep trying, but if you're not getting that, is okay, maintain that score. If you're maintaining 60s or 70s, that is also fine, maintain that score. Once you get, like kuch karna hai and you try to do, what I noticed, right, either people sacrifice sleep. Obviously, right, you want to study more, so what will you do? You'll sacrifice sleep, you'll mess up your health, then you'll fall sick. 3 weeks you're out of in the bed, and then whole story goes for a toss. And then you will panic more, thinking like, yaar, mera pura backlog ho gaya. You got greedy and you messed up what is more important, right? But if you just sustain with that 60 60 60 60, and once the portion gets over, for your seniors, if you see, once the portion gets over, there's nothing new to learn. You will literally have time from November, say advance happens in May. You have 6 to 7 months of solid time where we can just sit and solve and solve and solve. Can you imagine your seniors 2024 batch ka, right? Few of them have revised full chemistry portion 4 times. 4 times full chemistry portion, organic, inorganic, and physical. You need to do that. What do you guys think? Sir, I read everything, I don't remember. You read once and you think you don't remember. Gods, people revise 5-6 times. 2022 batch, I still remember this guy Anuj, right? Normally, right, me being a physicist, I keep scolding people for not revising inorganic, because inorganic is free marks. If they'll ask you what is the color of CuSO4 5H2, blue, either you don't know, there's nothing to think. And people leave these kind of questions and come. Idiots. Getting it? So I tell them, inorganic chodna hi nahi hai. Without chemistry, you won't even enter 5,000 ranks. Take it from me. If you're getting it, without chemistry, you won't even enter 5,000 ranks. If your physics is good, then you will go up to maybe 1500s and thousands. If you really want to push more than 1000 max. Below 1000 rank, what decides is max. But up to 1000 physics. The reason is simple. Out of 5000 people, if you ask them what is your favorite subject, 4900 will say physics, or 4500 say will physics. Sabka favorite is physics. So even if you give a tough paper, they'll solve. So what decides between them is that. So again, I'm saying, if you're maintaining the cutoff, if you're maintaining that 60% score, I think if you can do this, you're doing fine. Don't panic. Focus on learning, solving more questions, solve more, have fun. When you don't get a question, instead of thinking, yeah, I'm not getting, think like, oh, there must be something here to learn. Why am I not getting this? Oh, once you get the answer, think like, oh, I'm such a stupid. You're getting it, just keep it lively and have it fun. Have fun. You ask anyone who cracked the exam and you ask them, यार exam में आपको क्या लगा? I said, यार initially थोड़ा tension था, but बाद में मजा आ रहा था. Think about it. Any exam which you have done till now, an exam which you have done well and scored well, after writing the exam, didn't you feel like that you did well even without seeing the answer key? You will get that feeling, when you have done the exam well, without even seeing the answer key, you have done it well. Ever felt that? Getting it? That's it. That is the kind of state you're trying to reach. You are confident. Again, trust me when I'm saying this. Marks are important, but this is how you get marks. You focus on your subject, you focus on yourself, you keep improving, marks will eventually come. The moment your focus shifts to something else, you will do all wrong things and things will take a toss. Keep this in mind, because I'm seeing some of you are still panicking. You still have a long way to go. Focus, learn, that's it. And maintain that 60-65%. That's it. Don't worry if you're not getting 90%. Anyways, let's go ahead. So work per energy, before jumping directly, let's do a little let's talk about this energy. So what is energy? Whoever is there with me in the foundation, we discussed this, if you remember. What is energy? Again, this is something I keep telling you. In physics, right, when you learn something, there is always a technical definition. There is always a definition for yourself. Right? For you to understand what is energy. What is energy, anyone? What do you guys think? This need not be a proper definition. It could be anything, an example or something. Let me tell you what I think about energy. The thing is, think of like this. Let's say 10,000 years back, when you're a cave person, right? You're sitting there in your cave and you came out one day and you saw on a hill, there is a big stone. That's called stone A. And similarly, on the ground, there is a similar stone B. Now you tell me, which stone are you scared of? A looks more scary, right? A looks more scary. Why? Not because A looks more scary. That is because you think, yeah, this one day this stone might fall and come and hit me and I might die or I might get injured. So stone A is more scary than stone B. So tell me one thing, are you really scared of the stone? If you're really scared of the stone, shouldn't you be scared of stone B also? So you're actually not scared of the stone, you're scared of the height of the stone. Higher the object, the more energy, you don't know the vocabulary, you're getting it. This person doesn't have the vocabulary to call it energy. This person knows something. This stone A has something more than stone B. I don't know what it is, but it is dangerous. You're making sense? That is how you start, right? That is your feeling. Same way, let's say there is a lake here filled with water, and then let's say there is a river which is flowing very fast. Now, if you have to cross the lake and cross the river, which one is more scary? The river. So are you really scared of water? No, you're not scared of water. What are you scared is the speed of the water. You're scared if you get into the river might drift you and you might get away, taken away. So you get scared of that. So you actually got scared of the velocity. So from that analogy, if you try to think what is energy, and now, like I said, right, exactly, we don't have the things to say. I can say it's a quantity. Now, I don't know what it is exactly, but it is some quantity possessed by a system due to its position. We call this potential energy. So later on, when the caveman learns language, he will call it something, and he must have called it energy. What it has something more. That something more is called energy. And due to its motion. We call this kinetic energy. So if you ask me, this is what I will say. School ka definition is ability to do work. Now the problem comes, what is work? And the moment you say that, I'll say, what is work? What is work? So again, if you ask me what is work, this is what I think. So transfer of energy, the process of transferring energy is called work. The process of transferring energy from one system to another. So be careful, now work and energy are not same. So if you ask in pure English, what is energy? Energy is a noun. What is a work? It's a verb. Verb is an action. The act of transferring energy is called work. What is energy? It's a quantity possessed by a system due to its position and velocity or in a motion. So if you have to give an analogy, think of like this. Imagine I have money, okay? So money is like energy. If I give money or take money, that act of giving and taking money, the withdrawal and deposit of money from the account is called work. Are you getting the difference? Work and energy are not same. Work is simply transfer of energy is called, work. Now, are you getting a bit of a grasp? What is exactly like what is work and what is energy? Technical difference is ability to do work, but that's what it means. So in pure English, energy is a noun and work is a verb. You can also define energy like this. Energy is a quantity possessed by, energy is present everywhere. Energy can neither be created nor destroyed. Energy simply changes from one form to another form. Studied in school. And the best part about this definition, if you remove the word energy and put God, it still works. God is everywhere, right? God can neither be created nor destroyed. God is always there, right? And God simply changes from one form to another form. So when you think about it, maybe science people and religious people, right, are not talking about two different things. We are just using two different words. Energy is what for science, and God must be the same thing, isn't it? If you think about it like that. So maybe religious people are trying to find what is God or energy in their own way, and we are trying to find it using max and all calculations and stuff. So end of the day, maybe we both are trying to go to the same thing. You're just calling it with a different word. It's like the way you call water, and in Telugu we call it manchinilu, or in Hindi call it pani. You're still talking about the same thing. Just vocabulary is different. Now, being a science people, right, that is how we think. Now, if someone says, God doesn't exist, then you have to prove it. You're a science guy, right? You have to prove it. Can you prove it? No. Then how can you say God is not there? We don't know. He can be there. He need not be there. So it is fine. If he's there, it is fine. He's not there, it is fine. Clear with this? So this is what I think about energy and now work. Next thing, now let's go to a more technical definition. So work, symbol is W. We'll not write big definitions and stuff. We'll just directly jump into it. So work done is integral F bar dot ds bar. Now, be careful here. This is quite an important thing. Most people goof it up. What is ds bar? ds bar is the displacement of the point of application of force. It's not the displacement of the body. the displacement of point of application of force. Let me show you what it means. Now, if F bar is constant, so that is an actual formula for work done. If the force is constant, then force will come out of the integral. Then your work becomes F bar integral ds bar. Then it is F bar dot S bar. This is what you studied in school, F bar dot S bar. That's a dot product. Huh? This is a dot product. Then it becomes Fs cos theta. This is what you studied in school. Work done is force into displacement into theta. So if this is force, this is displacement, and this is theta. In one dimension, if you plot an fx graph, now interestingly, you can have a graph on all the four quadrants. You know why? Previously we used to use time, na? Time can't be negative, but displacement can be positive or negative. So look at the graph, it's nice here. So this is a negative area. This is a negative area. This is a positive area. This is a positive area. Why? Think about it. In the first quadrant, f is positive, x is positive. F into x is positive. In the third quadrant, f is negative, x is negative. So work done is positive. Second and fourth quadrant, one of them is negative. So area under the fx graph. So work done is integral f dx. I took it in one dimension. This is the area under the graph. There, have a look at this. That's it. If you ask what is work mathematically, this is the definition. Integral f bar dot ds. ds is not the displacement. Don't say displacement. Say the full thing. Displacement of point of application of force. And let me show an example why it is important. Any doubts on this page? Clear? Can I go ahead? Let me show an example. Let's say we have a block here, 1 meter long. This is point A, this is point B. There is a wall here. This distance is also 1 meter. Now what you did, you started applying a force F of 10 newtons. This block started moving. It went and hit the wall and got compressed. So something happened and the block became half meter ka width. And the force is still there, 10 newtons. Now, if I ask you this question, right, can you tell me how much did point B move and can you tell me how much did point A move? What is the displacement of B? B traveled only from here to here, right? That is 1 meter. What is the displacement of A? Look at this. If this is half meter, then this is 3 by 2 meters. Na? The displacement of A is 3 by 2 meters. Now you tell me, if you say work done is force into displacement, which displacement will you take? The reason you never had a problem is because such a thing never happened. If the blocks get compressed, what will you take as displacement? So now from the formula, work done is force into displacement of the point of application of force. You are applying force on point A. I don't care about anything else. Displacement of point of application of force. which is F into SA, which is 10 into 3 by 2, 15 joules. Is that clear, everyone? You're not supposed to take 1. Getting the confusion? That's why I said, so don't read it like force into displacement. Then you'll get confused because you'll not understand what's the displacement here. Let me show you one more example, but have a look at this page. It's a decent question. Anyone not convinced with this, please ask. Let's see one more example. Let's say we have your chapati ka dough. And you're holding it by applying a force F. Now, when you're holding it, after some time, this chapati ka dough will start stretching. But you're still holding at the same place. Right? So the chapati ka dough stretches. What is the work done by the force? Positive, negative? Niharika got it. What is the work done? Again, ask yourself, what is the definition? Force into displacement of point of application of force. When you applied the force, did this point move? Did the point move? A did not move, God. A never moved. You're just holding it at the same height. You're just holding it, Nanansh. Displacement of A is 0. Therefore, work done is 0. Then who is doing the work? Gravity. mg was here, mg was here. Work done by gravity is not 0. Gravity is responsible for stretching the chapati dough, not you. Is this making sense? So if you're just holding the chapati dough and it is stretching on its own, no, you're not pulling it up. So you're just held by force. It is just held. You're not stretching it. Clear, everyone? Make sense? Let's see one more example. We have done this in foundation. You guys remember? Let's say we have a staircase. And we have a boy who is walking on the staircase. So the question is, find work done by, we can do this as a question only. Boy on staircase, how much work does this boy do on the staircase? Find the work done by the staircase on the boy. How much work does the staircase do on the boy? I just want positive, negative, 0. I don't want any values. So options will be like positive, negative, 0, can't say. Is the question clear? So we have a staircase, you have a staircase and you're climbing it up. So when you're climbing the staircase, how much work do you do on the staircase and how much work does the staircase do on you? Is it positive, negative, or 0? Think, I'll give you 30 seconds. Again, go back to the basic definition, ask yourself, what is work done? Force into displacement of point of application of force. So let's look at the boy. So we are doing work done by boy on staircase. So what is your system here? Staircase is your system. So draw the staircase. And what is the boy doing? The boy is pushing the staircase with N. This is the force by boy on staircase. Your normal reaction, you're pushing the staircase down. But tell me one thing, the point where you're pushing, this point, is this moving? You're pushing the floor down, but is the floor going down? Is at rest. Therefore, work done by boy on staircase is 0. You're not doing any work done on the staircase. Reverse. Work done by staircase on boy. Now, what is the system boy? Now, this is interesting. Look at here carefully. What is the staircase doing? The staircase is pushing you up. Perfect. This is point B. This is point A. Look at this. When you're walking, when your foot is on the staircase, that foot is not moving, isn't it? The leg which is on the staircase is not moving. The leg which is not touching the staircase is moving. So on A, force is not 0. Force is there, but displacement is 0. A never moves when you're touching. On point B, force is 0, but displacement is not 0. Is that making sense? The one leg which is moving, the ground is not applying force on that leg. The one leg where there is a force, that leg is not moving. It is always in contact. Therefore, work done is 0. And if you try to think about this logically also, think about it. When if suppose the same question, right? If you're standing on the escalator, answer would be different. Think about it. If this had been an escalator going with V, and when the boy is standing, the floor is pushing the boy, and this point is going this way, right? So there is an acute angle, and work done is positive. Obviously, when you stand on the staircase, you don't get tired. You go, when you stand on the escalator, you don't get tired. You go automatically. So then the question comes at exactly what is staircase doing then? So what is actually happening here is, when you're walking, you're using your bones and your muscles like a springs. You're getting it. Your foot is hitting the floor and getting compressed. The muscles are getting compressed. You're using your own internal energy to move yourself. So the floor is simply acting like a catalyst. It is taking your energy and transmitting it back to you, and that is why you're going up. So the staircase is like a catalyst. It takes your energy and gives it back to you in the form of a kinetic energy. Is that making sense? So this is also 0. No one does work. Because if work done by boy or staircase on boy, if anything is positive or negative, it means someone is losing energy. The staircase never moves. Is this clear, everyone? It's a good theoretical question. If this had been an escalator, the whole game would have been different. Let's see one last one. Let's do something a little more number-based. In next class, when we catch up, we'll do again some more theory bits like this. 10 kg, mu is 0.2. F is 20 root 2. 45 degrees. Initially at rest. Find work done by friction and the external force in 2 seconds. There, your NLM is back. You're applying a 20 root 2, block is 10 kg, 45. I kept a trap also. I kept kinematics also. I brought NLM also. I brought friction also. Nay, Purvaja, you fell into the trap. Figured it out? Whoever took N is equal to mg, slap yourself. Try. 2 minutes, finish off. Last one for the day. Just try. I'll be just back in a minute. (16 by 5). 16 newtons, 12.8. I'm not sure. Friction will be negative, huh? Don't forget the sign. Step 1, choose a system, draw the free body diagram. This will be F ka component 20, F ka component 20, mg 100, normal reaction, friction, F max because it will slip. N is 80, F max is 16. There is an acceleration. 20 minus F max is equal to ma. So A is equal to 0.4. Displacement S is equal to ut plus half at square. U is 0, half, 0.4, and that's 2 square. So it has moved 0.8 meters. Work done by force is Fs cos 45. That's 20 into 0.8, that is 16 joules. Work done by friction is minus F into S, which is minus 16 into 0.8, minus 9.6 joules. Am I right? Did I mess up? 12.8 कहाँ से आ रहा है? Did I mess up क्या?
So 16
So
at
16 into 8 is 12 point.
I'm just testing you guys. 16 though, I thought it was 12. Clear? This is a good mains level question. Most people goof up that part. They take n is equal to mg, they think the block is not moving, and the first option will be 0. In a excitement, you mark it and come. So be careful with this. Okay, so that's the last one for the day. We'll wrap up with this. And next class, when we catch up, we will do more about force. We have some really good ones. You know, we have integration based, and we have some really good models. So next class, we'll work on that. I think full class will go for work part only. And then we should be able to wrap up this chapter in 6 classes. So before Diwali ka break, we will wrap up this chapter and then I'll give you a break. Okay, with that we'll end up for the day. Last week ka paper do resolve. We will discuss that in the Thursday as usual. So the paper was on a little higher side, but few questions were repeated. Okay, so any doubts in today's class? Any other doubts you can stay back and ask, and paper ka doubts we'll see it on Thursday. So any other doubts? Do stay back or else we'll